At 9:17, one order created two valid shipments. Both told the warehouse to pack the same laptop. The customer clicked buy once. Courier pickup was 43 minutes away. Maya had to stop one box before both left. She had 30 minutes to explain the second shipment. Support sent the first message. The customer placed one order. Maya read it twice. Her first suspect was still the button. Double clicks create duplicates. The front-end engineer opened the browser log. One click, one request ID. Then he wrote, I can find one request. That cleared the button. A duplicate result does not prove a duplicate input. Count every handoff. Maya followed request R418 into the API. It created one shipment job. The queue accepted one message, ship 01847. Nothing appeared twice. The API became suspect anyway. Maybe it published twice, then hid one line. A backend engineer checked the second log. The publish log shows one message. Now both easy answers were gone. One customer action entered, one queue message left. Yet, two valid shipments waited at the warehouse. Then Maya opened the worker logs. At 9:17:04, shipment created. At 9:17:11, the same message started again. Same message ID, different delivery number. Two deliveries of one message. A delivery is one time the queue hands that job to a worker. That was the fact. It was not yet the answer. Maya checked the first delivery again. Its shipment record was complete and valid. The shipment had not failed. The warehouse sent another message. Both boxes are on the same pallet. Loading had already started. The pallet was moving while the investigation remained open. Ops asked whether they should delete one record. Maya said, hold the second box, do not delete anything yet. She needed to identify the wrong record before changing either. Deleting the symptom would hide the cause. The same message could return tomorrow. Maya rebuilt the path. A message arrived. A worker performed the job. The shipment record survived. Then the message arrived again. She placed both delivery histories side by side. Delivery 1 had a start line. It had a shipment created line. Its usual final line was missing. Creation was visible. Completion was silent. She opened the queue's view. It still marked the message unfinished. The queue was waiting for a final signal that never appeared. The work was done. The queue disagreed. A platform engineer checked the process history. That worker stopped between those two lines. Maya had been asking why the message was sent twice. Now she asked a better question. Why had the queue never heard it was done? A queue is a waiting line for jobs. A worker takes one job, performs it, then reports completion. That final report is an acknowledgement. It tells the queue, you can forget this delivery. It is separate from the work itself. The first worker created the shipment. That durable record survived. Before RabbitMQ recorded the acknowledgement, the worker process ended. RabbitMQ still held an unacknowledged delivery. It could not inspect the shipment database. It only knew its worker had gone silent. So it returned the message to the queue. Another worker received it and ran the same handler. This was the same message, not a new publish. That handler created another shipment. Both records were valid. Both described the same order. Nothing entered the system twice. Finished work was performed twice. A new delivery was not new business intent. The queue protected the job from disappearing. The handler did not protect the shipment from repetition. Someone suggested acknowledging first. That would stop this redelivery. It could also lose a shipment. The worker might acknowledge, stop, and never create the record. No message would remain to retry it. Maya rejected that trait. She needed completion without loss and repetition without damage. Maya stopped trying to make the message arrive once. She made the second arrival harmless. The business already had one stable fact. One order should own one shipment. She used the order ID as the shipment key. The database now enforced one shipment per order ID. Two workers could arrive together. The constraint would still decide once. The handler tries to create the shipment. If that key exists, it returns the existing record. The database performs that as one protected action. A separate check followed by an insert could still raise. This property is called idempotence. Run the handler again. Its final stored result stays the same. It is like pressing a lift button twice. The destination is already recorded. Only after that durable result exists does the worker acknowledge the delivery. First arrival, create the record. Second arrival, return it. Both can finish safely. Here, that record triggers warehouse work. An outside shipping provider would need the same stable key at its own boundary. Maya deployed the change. The warehouse pulled the second box before the courier left. The first shipment continued. One fix is not proof. Maya wanted a test that failed without it. So she forced the exact failure window. The test publishes once. It creates the shipment, then ends the worker before acknowledgement. The same message is delivered again. One publish, two deliveries. With the naive handler, two shipment records. With the order key, one. The first test exposed two records. Maya added the key. The same forced failure then left one. This is a small node simulation. It is not a live queue or a real warehouse. The failure window it recreates is real. The test stays in the suite. If someone removes the protection, it fails before another box moves. One click, one request, one message, two deliveries. That difference solved Maya's case. A duplicate result did not prove a duplicate input. Trace every handoff. Assume a worker can run again. Give the final action one stable business key. Then the second run changes nothing. The courier left with one laptop. The prevention test stayed behind.